Okay, guys. Sorry for the delay. Am I audible to you? Santosh? Santosh, are you there?
Yes, sir.
Okay. Okay. First of all, good morning to all of you. Okay. So today I'm going to conduct a technical training for you guys. Okay, in the subject engineering mechanics. So you all already studied engineering mechanics in the first year itself. Okay. So I'm going to uh, revise that subject. Okay. You guys, please recollect what you learned in those semesters. Okay. So first, definition: engineering mechanics. So engineering mechanics is the branch of engineering science which deals with the principles of mechanics along with their applications to engineering problems. It is subdivided into following two main groups. So engineering mechanics is a branch of science. Okay, deals about the principles of mechanics. If the when you ask define engineering mechanics, or what is meant by engineering mechanics, it's a branch of science only, deals about the principles of mechanics. Okay, so it is subdivided into two groups: statics and dynamics. You all know what is statics and dynamics. Statics means at the state of rest, dynamics means at the state of motion. Okay, so statics is also a branch of engineering mechanics, deals with the forces and their effects while acting upon the bodies at rest. Okay, so it deals with the forces only, okay, and their effects acting on the bodies at the rest. But dynamics, it also deals about the forces and effects acting on the bodies in motion. Okay, that is the difference. So statics means at the state of rest. Okay, dynamics means at the state of motion. It is further subdivided into following branches: kinetics and kinematics. Okay, so dynamics is further subdivided into two branches: kinetics and kinematics. So kinetics means it is a branch of dynamics, deals the bodies in motion due to the application of forces. Okay, so one object is in motion. Okay, you are applying an extra force on that object. Okay, a body. Okay, so because of the force, the body tends to change its direction or movement further more. Okay, so you are considering that force also. Okay, so if you consider that external force acting on the body means that is kinetics. Kinematics, without considering that external forces. Okay, so it deals about the bodies in motion only. Kinematics also a branch of dynamics which deals the bodies in motion without taking into account the external forces which are responsible for the motion. Okay, so have you got it? So what is engineering mechanics? So engineering mechanics is branch of science. Okay, deals with the principles of mechanics along with their application. So engineering mechanics is further subdivided into two branches. Okay, statics and dynamics. So statics means at the state of rest, dynamics means at the state of motion. Okay, deals about the forces and its effects only, but the body is in motion, but the static, the body at rest. Okay, so dynamics is further subdivided into two types. Okay, kinetics and kinematics. Kinetic means you are also considering the external force which cause the motion, but kinematics without considering the external force which cause the motion. Okay, so that is the difference in between kinetics and kinematics. Okay, so after that, force. Okay, so what is force? So force, it may be defined as an agent. Okay, it is an external agent which produces or tends to produce, destroy or tends to destroy the motion of a body. Okay, so the force is an external agent which makes an object to move, or it makes an object to stop. Okay, so force while acting on a body may change the motion of a body. Okay, retard the motion of the body. Change the motion means uh, it will make the body to move. Return the motion means it will make the it will make the object to stop. Okay, whether the object is moving motion means it will make the object to stop. That is the retard. Okay, opposing force. Then balance the forces already acting on a body. Okay, for some cases, for equilibrium position, we are applying an external force for balancing purpose. For give rise to the internal stresses in a body. Okay, it gives an external rise. Okay, for internal stresses. Okay, so these are the applications of the forces. Okay, so in order to determine the effects of force acting on a body, we must know the following characteristics of the force. Okay, so what are the characteristics of force? Means the magnitude of the force. Okay, so each and every force has a different magnitude. Okay, each and every person can give their own magnitude. Okay, so magnitude of the force is first characteristic. Second, the line of action of the force. In which line of action, in which direction the force is acting. Okay, so that is also characteristics. Then nature of the force, that is push or pull. Whether we are applying a compressive force or tensile force. So nature of force is a characteristic. The point which the force is acting. Okay, where the force is acting, that is important characteristics. Okay, so there are four characteristics. Okay, so first one, the magnitude of the force. Magnitude means the value only. Okay, how much amount of force we are applying. Then the line of action, the line of action of the force, whether we are acting in the same line of action already the force is acting, or we are acting in the opposite direction. Okay, then the nature of the force, whether we are applying compressive force or the tensile force. Then the point at which the force is acting. Okay, so these are the characteristics of the forces. So next, units. Okay, in MKS system of units. So the how we are denoting the units. Okay, so there are different types of symbols to mention the units and all. Okay, so MKS units. MKS means meter Kelvin second. Okay, in MKS system of units, the magnitude of force is expressed in kilogram force. Okay, uh, but in a SI system of unit, the force is expressed in newtons. Okay, so we are all using SI system only. Okay, system international. So 1 kilogram force is equal to 9.81 Newton. Okay, you noted this 1 kilogram force is equal to 9.81 Newton. So far we saw about engineering mechanics. What is engineering mechanics or define engineering mechanics? And engineering mechanics is further divided into two groups: statics and dynamics. So we learned what is statics and dynamics. So dynamics is further subdivided into kinetics and kinematics. Okay, we learned what is kinetics and kinematics. These are all branch of engineering mechanics only. So statics, dynamics, kinetics, kinematics are all branches of engineering mechanics only. So after that, we learned about force. So force is nothing but an external agent. Okay, it will not present internally. Okay, we have to apply externally only. So force is an external agent. So why we are applying the force, or what are the application of force means, to change the motion of the body, or to retard the motion of the body, to balance the system, or to give the rise to internal stresses. So these are the application of force. And we learned about the characteristics of force. So what are the characteristics? There are four characteristics. And we learned about the units. Okay, so there are many units, but yeah, they mentioned about MKS and SI only. Okay, so in SI we often we use SI system units only. So SI means System International. So in System International, 1 kilogram force is equal to 9.81 Newton. Okay, so after that, resultant force. So what does it mean by resultant force? So resultant force means in a system, okay, or an object, there are many number of forces will be act or may act. Okay, so in that type, so because of those all the forces, there will be a resultant forces. Okay, so that is the resultant. Because of number of forces acting in a system, there will be a one common resultant force. Okay, so resultant force is a single force which produces the same effect as produced by all the given forces. Okay, so the produces the same effect. Resultant force is a single force, produces same effect. Okay, as produced by all the given forces acting on a body. The resultant force may be determined by the following three laws of forces. Okay, so we can calculate the resultant force by using three laws. Okay, so those three laws are: first one, parallelogram law of forces; second one, triangle law of forces; and third one, Paulian law of forces. Okay, so by using these three laws, we can calculate the resultant force. Okay, so first we'll see parallelogram law of forces. So parallelogram law of forces states that if two forces, okay, so if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram. Okay, so you know what is parallelogram. Okay, so parallelogram is this one only. Okay, there are four sides. Okay, so this is the parallelogram. Okay, so what they are saying, if two forces acting simultaneously, so two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram. So two adjacent sides of the parallelogram, they take this OQ and OP as the two adjacent sides of this parallelogram. Okay, in these two sides, two forces are acting simultaneously. Okay, so force OQ is acting in the upward direction and the force OP or P acting in the right hand side direction. Okay, so then their resultant force, then their resultant may be represented in magnitude and direction by the diagonal of the parallelogram. Okay, so because of these two forces, that is Q and P, then the resultant of these two be represented in magnitude and direction of the diagonal of the parallelogram. Okay, which passes through their points of intersection. Okay, which passes through their points of intersection. The intersection point is O. Okay, so this is the parallelogram law of forces. Okay, so what is parallelogram forces? Are defined parallelogram law of forces means if two forces acting at 2 points, okay, simultaneously on a particle be represented in magnitude by the two adjacent sides of parallelogram. Okay, so two forces Q and P acting in the adjacent sides of the parallelogram, then the resultant of these two forces Q and P may be represented in magnitude and direction by the diagonal of their parallelogram. Okay, so R is the resultant force. Okay, acting diagonally, which passes through their points of intersection. Okay, so this is the parallelogram law of forces. Okay, so for this only, okay, the equation, the resultant force R is equal to square root of P square plus Q square plus 2PQ cos theta is the mathematical representation for calculating resultant force R. Okay, so for R makes an angle alpha with their force P, then tan alpha is equal to Q sin theta divided by P plus Q cos theta. Okay, so these are the formulas. Okay, so you have to remember these formulas. So in parallelogram for law of forces, the resultant force formula is square root of P square plus Q square plus 2PQ cos theta, where P and Q are the forces in the adjacent sides of the parallelogram, and theta is the angle of the inclination between those forces. Okay, P and Q. Then tan alpha is equal to Q sin theta divided by the whole divided by P plus Q cos theta. Okay, so alpha is the angle between the force P and the resultant force R. Okay, so we can calculate the R and tan alpha and all. So next law is triangle law of forces. So triangle law of forces, okay, it states that if two forces acting simultaneously on a particle, okay, be represented in magnitude and direction by the two sides of the triangle taken in order, then the resultant may be represented in magnitude and direction by the third side of the triangle taken in opposite order. Okay, so it is similar to parallelogram law of forces only. Okay, parallelogram means four sides are there. Okay, so two forces represent the two adjacent sides of the parallelogram, then the resultant will be the diagonal of that parallelogram. Okay, that is parallelogram. But in triangle law of forces, okay, two forces acting simultaneously on a particle represented in magnitude direction by the two sides of the triangle taken in order. Okay, by the two sides of the triangle, then the resultant force may be the third side of the triangle but taken in opposite order. Okay, so this is the triangle of forces. Okay, for example, you consider this triangle. Okay, in this figure, okay, O and this point, we'll name it as A. Okay, O A B. So this is a triangle. Okay, don't consider this portion. Okay, consider this bottom portion alone. So this is a triangle. Okay, two forces acting simultaneously represent magnitude and direction. So two forces that are R P. Okay, so R or Q. You name this as a Q. So this one is Q. Q and P. Okay, are the two forces acting in the two sides of the triangle. Then the resultant force will be acting the third side of the triangle in opposite direction. Okay, in this direction, the resultant force will be act. Okay, have you got it? Okay. Third one, Polygon law of forces. So Polygon law of forces states that if a number of forces acting simultaneously on a particle be represented in magnitude and direction by the sides of the polygon taken in order, then the resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite order. Okay, so we all know in the name of the itself, we understand. Okay, parallelogram means four sides. So in that two forces are acting on the two sides, two adjacent sides of the parallelogram, then the resultant force will be acting in the diagonal of the parallelogram. So that is parallelogram. In triangle of forces, if two forces acting on the two sides of the triangle, then the resultant force acting on the third side of the triangle in opposite direction. In polygon law of forces, we know the meaning of polygon itself. Polygon means more number. Okay, more than 600. Okay, so number of sides are more. So polygon means more number of sides. Okay, so no more number of forces acts in that. Okay, in each and every direction there will be a force. Then the resultant force will be the closing side of the polygon. Okay, in opposite direction. Okay, that only they mentioned here. It states that if a number of forces acting simultaneously on a particle, okay, be represented in magnitude and direction by the sides of polygon taken in order, then the resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite order. Okay, so have you got it? Or else do you have any doubt? Mongna Priya,
Sir,
டவுட் எதாவது இருக்காமா?
no, sir.
இப்போ இதுவரை என்ன பார்த்துருக்கோம்னா இன்ஜினியரிங் மெக்கானிக்ஸ்னா என்ன, ஓகே, அப்புறம் ஸ்டாட்டிக்ஸ், டைனமிக்ஸ். ஸோ டைனமிக்ஸில் கைனடிக்ஸ், கைனமேட்டிக்ஸ், அப்புறம் ஃபோர்ஸ். ஓகே, ஃபோர்ஸோட கேரக்டரிஸ்டிக்ஸ் என்ன, அப்புறம் ரிசல்டன்ட் ஃபோர்ஸ்னா என்ன. ஓகே, ரிசல்டன்ட் ஃபோர்ஸ் கால்குலேட் பண்ணுறதுக்கு த்ரீ லாஸஸ் இருக்கு. ஸோ அந்த த்ரீ லாஸ் தான் வந்து ஃபர்ஸ்ட் ஒன் பேரலோகிராம், செகண்ட் ஒன் ட்ரையாங்கிள் லா ஆஃப் ஃபோர்ஸஸ், தேர்ட் ஒன் பாலிகன் லா ஆஃப் ஃபோர்ஸஸ். ஓகேவா? ஸோ எல்லாமே பேரலோகிராம்னா நாலு சைடு இருக்கும். ஸோ ஏதோ ரெண்டு சைடில் ஒரு ரெண்டு ஃபோர்ஸ் சைமல்டேனியஸாக ஆக்ட் ஆகுது, ரெண்டு அட்ஜஸ்ட் சைடில். அப்போ அந்த ரெண்டு ஃபோர்ஸோட ரிசல்டன் வந்து அதோட டயக்னலில் நம்ம மென்ஷன் பண்ணுறோம். ஓகே, இது பேரலோகிராம் லா ஆஃப் ஃபோர்ஸஸ். ட்ரையாங்கிள் லா ஆஃப் ஃபோர்ஸஸ்னா ட்ரையாங்கிள் தான் த்ரீ சைட்ஸ் இருக்கும். ஸோ ரெண்டு சைடில் வந்துட்டு நம்ம ஃபோர்ஸ் அப்ளை பண்ணியிருக்கோம் சைமல்டேனியஸாக. அப்படிங்கும்போது அந்த ரெண்டு ஃபோர்ஸோட ரிசல்டன் ஃபோர்ஸ் வந்து தேர்ட் சைட் ஆஃப் த ட்ரையாங்கிள் இன் ஆப்போசிட் டைரக்ஷன். ஸோ சேம் த பாலிகன் லா ஆஃப் ஃபோர்ஸஸ். ஸோ பாலிகன்னா மோர் நம்பர் ஆஃப் சைட்ஸஸ் இருக்கும். ஓகே, மோர் தென் 6. ஓகே, ஸோ நம்பர் ஆஃப் சைட்ஸ் அதில் அதிகமாக இருக்கும். ஸோ அதில் எல்லாத்துலேயுமே ஃபோர்ஸ் ஆக்ட் ஆகுது. ஓகே, இன் டைரக்ஷன், மேக்னிடியூட்லாம் மென்ஷன் பண்ணியிருப்பாங்க. ஸோ அந்த எல்லா ஃபோர்ஸோட ரிசல்ட் அண்ட் ஃபோர்ஸ் பார்த்தீங்கன்னா க்ளோசிங் சைட் ஆஃப் பாலிகன். ஓகேவா? இன் ஆப்போசிட் டைரக்ஷன். ஓகே, சந்தோஷ், சந்தோஷ்,
எஸ் சார்.
உனக்கு ஏதாச்சும் டவுட் ஏதாவது இருக்காங்கண்ணா?
இல்லை சார்.
டவுட் ஏதாவது இருந்ததுன்னா மெசேஜ் இதில் வந்து டைப் பண்ணுங்க. ஓகே, okay, I'll continue next. So after completing these three classes, next notes. Okay, some important points. The resultant of more than two intersecting forces. Okay, the resultant of more than two intersecting forces may be found by resolving all the forces horizontally and vertically. In such cases, the resultant of the force is given by R is equal to square root of summation h square plus summation v square. Okay, so in previous three cases, in these three laws, parallelogram law of forces, triangle law of forces, and polygon law of forces. Okay, so in these cases and all, okay, two forces are only acting and intersecting at a common point. Okay, But if more than two forces intersecting, more than two intersecting forces acting at a meeting at a common point, okay, so if more number of forces, more than two number of forces are meeting at the same point means, then we have to resolve, okay, horizontally and vertically. Okay, so for those cases, the formula or resultant force formula is square root of summation h square plus summation v square. We know what is a summation h, summation v. Summation h means sum up of horizontal forces, summation v means sum up of vertical forces. Okay, so tan alpha is equal to summation v by summation h. Okay, the resultant r makes an angle alpha with horizontal. Okay, for calculating that angle alpha, the formula is tan alpha is equal to summation v by summation h. Okay, okay, you understand? The note one. These three laws are same because only two forces meeting at a point. But there are some cases, okay, more than two number of forces meeting at a point. In those cases, we have to use this formula. Okay, we have to solve the resultant force by using by resolving horizontally and vertically. Okay, if only two forces meeting at a point means, we can use the above three laws: parallelogram law of forces, triangle law of forces, or polygon law of forces. If more than two forces acting at a common point means, then we have to resolve horizontally and vertically. Okay, for calculate for the calculation of resultant force. So that is the first point. Then second point, if the resultant of a number of forces acting on a particle is zero, then the particle will be in equilibrium. Okay, if the resultant force is zero means what? That system is in an equilibrium position. Okay, such a set of forces whose resultant is zero are known as equilibrium forces. Okay, that system is equilibrium condition. The force which brings the set of force in equilibrium is called equilibrium. Okay, so there are number of forces are acting in the system. Okay, we are applying an external force. Okay, only one external force. Okay, because of that external force, that whole system brings to brought to a equilibrium condition. Then that's force is named as equilibrium. Okay, equilibrium. It is equal to the resultant force in magnitude but opposite in direction. Okay, so that equilibrium force will be equal to the resultant force in magnitude but opposite in direction, so that only it brought the system to a equilibrium position. Okay, so that is the second point. Third point, a number of forces acting on a particle will be in equilibrium. Okay, when summation h is equal to 0, summation v is equal to 0. Okay, so number of forces acting on a particular in a system, there are number of forces means, and also that system is in equilibrium position. Okay, that means summation h is equal to 0, summation v is equal to 0. So that is the meaning. Okay, in a system, summation is equal to 0 and summation v is equal to 0 means that type of system is an equilibrium condition. Okay, so these are three important notes. Okay, you have to consider by applying the law of forces. Okay, so parallel law of forces, triangle law of forces, polygon law of forces. Okay, in these three laws, only two forces meeting at a common point. Okay, so there are some other cases, more than two forces meeting at a point. In that time, we have to apply the you have to resolve the forces horizontally and vertically for the calculating resultant force. Okay, so three important notes. So next one is system of forces. Okay, system of forces, there are more number of systems. Okay, so when two or more than two forces acts on a body, they said to form a system of forces. Okay, so if two or more than two forces acting on a body means that is a system of forces. Okay, so following the various system of forces, the first one, coplanar forces. Okay, coplanar system, concurrent forces, coplanar concurrent, coplanar non-concurrent. Okay, so non-coplanar concurrent, non-coplanar non-concurrent. Okay, there are many system. Okay, here they're mentioning important six systems only. Okay, I'll teach one by one. So first one is coplanar forces. Okay, so forces whose line of action lie on the same plane are known as coplanar forces. Okay, so there are number of forces, more than two number of forces acting in the same plane means that is known as coplanar forces. Okay, you guys are understanding? Ashwin,
Sir.
என்னக்கண்ணா புரியுதா? கோப்ளானர் ஃபோர்ஸஸ்னா என்னன்னு புரியுதா?
Yes, sir.
ஒரு பிளேன் தான், ஒரு பிளேன்லயே எல்லா ஃபோர்ஸும் ஆக்ட் ஆச்சு அப்படின்னா அந்த சிஸ்டம் வந்து கோப்ளானர் ஃபோர்ஸ். ஓகேவா?
Okay, sir.
Okay. So next one is concurrent forces. The forces which meet at one point are known as concurrent forces. Okay. Third one, coplanar concurrent forces. The forces which meet at one point and their line of action also lie in the same plane are called coplanar concurrent forces. Okay, so coplanar non-concurrent means the forces which do not meet at one point but the line of action lie on the same plane. Okay, so first of all, so coplanar force means all the forces are acting in a same plane, so that is coplanar forces. Second one is concurrent forces. Concurrent forces means there are number of forces meeting at a point. Okay, that is concurrent forces. Okay, third one is coplanar concurrent. So coplanar concurrent means it is the combination of coplanar and concurrent. So what is coplanar? All the forces acting in a same line, same plane. Okay, concurrent means all the forces acting in a or meeting at a common point. Okay, so combination of these, okay, that is coplanar concurrent forces. So number of forces acting in a plane, and also they are those forces are meeting at a common point. Okay, so that is the coplanar concurrent forces. Fourth one is coplanar non-concurrent forces. Okay, so coplanar non-concurrent means coplanar means more number of forces. Okay, number of forces acting in a same plane. So non-concurrent means they do not meet at a common point. Okay, so that is coplanar non-concurrent forces. So the forces which do not meet at one point but their line of action lie on the same plane. Okay, so this is known as coplanar non-concurrent forces. Okay. Fifth one, non-coplanar non-coplanar concurrent forces. So non-coplanar means coplanar means acting in a common one plane. Non-coplanar means there are number of forces acting in different planes. Okay. So one force is in one plane, another force is in another plane. Okay, so the force which meet at one point, concurrent means meeting at a common point. Okay, so the force meeting at a common point, okay, which meet at one point but their line of action do not lie on the same plane are known as non-coplanar concurrent forces. Okay, so non-coplanar concurrent forces mean the forces may be in different planes but meeting at a common point. Okay, so that is non-coplanar concurrent forces. Last one, non-coplanar non-concurrent forces. So non-coplanar means the forces may be in different planes. Okay, there are number of forces in different planes acting on a different planes. Non-concurrent means they do not meet at a common point. Okay, so non-coplanar non-concurrent forces means the forces which do not meet at one point and their line of actions do not lie on the same plane are called non-coplanar non-concurrent forces. Okay.
Okay, sir.
Vignesh Kumar. Vignesh Kumar. Vignesh Kumar, are you there? நோங்கண்ணா பிரியா.
சார்
உனக்கு புரிஞ்சுதாமா?
புரியுது சார்.
சிஸ்டம் ஆஃப் ஃபோர்ஸஸ்.
எஸ் சார்.
சிஸ்டம் ஆஃப் ஃபோர்ஸஸ்ல கோப்ளானர் ஃபோர்ஸஸ்னா என்ன?
ஹலோ,
என்னம்மா கோப்ளானர் ஃபோர்ஸஸ்னா என்ன?
சார் அந்த ஃபோர்ஸ் வந்து அந்த லைன் ஆஃப் ஆக்ஷன்லயே இது அந்த கோப்ளானர் ஃபோர்ஸஸ் வந்து சேம் லைன் ஆஃப் ஆக்ஷன்லயே அது இதாயிருக்கும் சார்.
ஒரு பிளேன் இருக்குன்னா, ஓகே, ஸோ அந்த ஃபோர்ஸ் எல்லாமே நம்பர் ஆஃப் ஃபோர்ஸஸ் வந்துட்டு எல்லாமே ஒரே பிளேன்ல ஆக்ட் ஆகும். ஓகேவா, சேம் லைன் ஆஃப் ஆக்ஷன்லேயே இருக்கும் அண்ட் ஆல்சோ இட் ஆக்ட்ஸ் ஆன் தி சேம் பிளேன் இட் செல்ஃப். ஸோ அதுதான் வந்து கோப்ளானர் ஃபோர்ஸ். ஓகே, ஸோ பிளேன்னா உனக்கு தெரியும்ல, நீ இன்ஜினியரிங் கிராஃபிக்ஸ்ல படிச்சிருப்ப. வெர்டிக்கல் பிளேன் ஹரிசான்டல் பிளேன்ல படிச்சிருக்கியா?
எஸ் சார்.
வெர்டிக்கல் பிளேனை வந்துட்டு ரிசால்வ் பண்ணும்போது அது என்ன இதாகுது, என்ன வியூக்கு போகுது? வெர்டிக்கல் பிளேன் ஹரிசான்டல் பிளேன் இருக்கும். நீ ஒரு லைன் ஆர் இமேஜ் முன்னாடி இமேஜின் பண்ணிக்குவ. ஓகேவா, அதை ப்ரொஜெக்ட் பண்ணுவியா? இப்போ வெர்டிக்கல் பிளேனை ப்ரொஜெக்ட் பண்ணும்போது அது என்ன வியூ
சார்? நம்மளுக்கு
டாப் வியூவா?
எஸ் சார்.
ஹரிசான்டல் பிளேன்ல இருக்க இமேஜ் ப்ரொஜெக்ட் பண்ணும்போது அது என்ன வியூ?
ஃப்ரண்ட் அந்த மாதிரி வரும் sir.
அதான் ஹரிசாண்டல் பிளேன்னா டாப் வியூ. ஓகே, வெர்டிக்கல் பிளேன்ல ஃபாலோ ஆகுற இமேஜ் வந்துட்டு
Side.
ஃப்ரண்ட் வியூ. ஓகே. இப்போ அதே
Yes
தான்.
sir.
இப்போ வெர்டிக்கல் பிளேனுக்கு ஒரு பிளேன். ஓகே, அந்த பிளேன்ல மட்டும்தான் ஃபோர்ஸ் ஆக்ட் ஆகுது அப்படின்னா அது கோப்ளானர் ஃபோர்ஸ். ஓகே, இப்போ வெர்டிக்கல் பிளேன்லயே ஒரு ஃபோர்ஸ் இருக்கு, ஹரிசாண்டல் பிளேன்லயே ஒரு ஃபோர்ஸ் இருக்கு அப்படிங்கும்போது பார்த்தீங்கன்னா அது வந்துட்டு பார்த்தீங்கன்னா கன்கரண்ட் ஃபோர்ஸஸ். கன்கரண்ட் ஃபோர்ஸ்னா காமன் லைன். ஓகே, நான் கோப்ளானர் ஃபோர்ஸ். ஓகே, கோப்ளானர்னா acting in the same plane itself, acting in the same line of action and also in the same plane, other coplanar forces. Okay, non coplanar na maybe in different plane, vertical plane le or force act agum, horizontal plane le or force act agum. Okay, அப்புறம் பாத்தீங்கன்னா கன்கரண்ட் ஃபோர்ஸஸ்னா நம்பர் ஆஃப் ஃபோர்ஸஸ் இருக்கு, மோர் நம்பர் ஆஃப் ஃபோர்ஸஸ் இருக்கு. எல்லா ஃபோர்ஸுமே ஒரு காமன் பாயிண்ட்ல மீட் ஆகுது. ஓகேவா? அது மேபி நீ வந்துட்டு வெர்டிக்கல் பிளேன்ல இருக்கிற ஃபோர்ஸ் இல்ல ஹரிசாண்டல் பிளேன்ல இருக்கிற ஃபோர்ஸ் எல்லாமே ஒரே பாயிண்ட்ல மீட் ஆச்சு அப்படின்னா அது கோப்ளானர் கன்கரண்ட் ஃபோர்ஸஸ். ஓகேவா? ஒரே பிளேனு ஒரே பாயிண்ட் அப்படின்னா கோப்ளானர் கன்கரண்ட் ஃபோர்ஸஸ். நான் கோப்ளானர் நான் கன்கரண்ட் ஃபோர்ஸஸ்னா டிஃப்ரெண்ட் பிளேன்ல இருக்கும், மீட் ஆகாது. ஓகே, ஸோ இந்த 6 சிஸ்டம் ஆஃப் ஃபோர்ஸஸ். நெக்ஸ்ட் ஒன் வந்து லாமிஸ் தியரம். ஸோ லாமிஸ் தியரம் எல்லாத்துக்குமே தெரியும். So Lami's theorem states that 3 coplanar forces. Okay, so just now only we studied what is coplanar forces. Coplanar forces means forces acting in a same line of action and also acting in a same plane. Okay, so see this diagram. It acts in a same plane only. Okay, so there are 3 forces P, Q, R acting in a same plane. Okay, and also it is meeting in a common point. Okay, this point maybe origin O. Okay, so this is coplanar concurrent forces. So it states that 3 coplanar forces acting at a point B in equilibrium. Okay, so 3 coplanar forces acting at a point and B in equilibrium. If it wants to be in equilibrium means, then what is the condition? Then the condition is each force is proportional to the sine of the angle between the other two forces. So each force is proportional to the sine of the angle between the other two forces. So P by sine alpha. So mathematically P by sine alpha, Q by sine beta, and R by sine gamma. Okay, so each force is proportional to the sine of the angle between the other two forces. Okay, so mathematically just P. So P. Okay, each force is proportional to the sine of the angle between the other two forces. Okay, sine of the angle for P, the other two forces Q and R. So okay, the angle between Q and R is alpha. Okay, the sine of the angle between the other two forces for P is P by sine alpha, and for Q is P and R, the angle is beta. Okay, so Q by sine beta, and for R is the other two forces are Q and P. Okay, the angle between those forces is gamma, so R by sine gamma. So finally mathematically the Lami's theorem is P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. Okay, so where P, Q and R are the 3 forces and alpha, beta, gamma are the angles, okay, between the forces. Okay, so here I stops. Okay, I'll see you next class. Thank you.
Thank you, sir.